build logs just leaked your API key in plain text. A developer bypassed the credentials binding plugin and hard-coded it directly. Let's break down Jenkins pipeline best practices, how it works, and the exact mistake behind that failure. Jenkins pipeline lets you define your entire software delivery process as code in a file called a Jenkinsfile. There are two syntaxes: declarative, which is structured and opinionated, and scripted, which offers full groovy flexibility. Best practices focus on making these pipelines reliable, maintainable, and debuggable. Declarative pipeline enforces a clear structure with pipeline, agent, stages, and steps blocks. This reduces groovy script errors and makes pipelines easier to debug. Scripted pipeline gives you full control, but can lead to spaghetti code. In production, we found that declarative pipelines reduced syntax-related failures by 80%. The Jenkins pipeline linter validates your Jenkinsfile syntax without running it. You can use it via curl or Jenkins CLI. Integrating it into a pre-commit hook catches errors before they reach production. This simple step would have prevented the missing bracket incident we started with. Your Jenkins file should live in your application repository, ensuring each branch has its own pipeline definition. For reusable logic like building Docker images or deploying to Kubernetes, create a shared library. This reduces duplication and centralizes changes. Always pin a specific version tag in the @library annotation to avoid unexpected breaks. Jenkins pipelines can fail for many reasons. Without error handling, a failed build might leave the environment in an inconsistent state. Use post conditions to handle cleanup and notifications. For example, always run clean WS to free disk space and send email only on failure to reduce noise. Hardcoding secrets like API keys in Jenkinsfiles is a security risk. Jenkins provides the credentials binding plugin to securely inject credentials. Use with credentials to bind secrets to environment variables. Never echo or use secrets directly in shell commands, as they may appear in logs. To speed up pipelines, run independent stages in parallel. However, too much parallelism can exhaust agents or cause resource contention. Use fail-fast true to abort all branches if one fails, and use lock steps to prevent concurrent access to shared resources like a deployment server. The input step pauses the pipeline waiting for user approval. This can cause pipelines to hang indefinitely if the approver is unavailable. Instead, use external approval systems like Slack bots that trigger pipeline resumption via webhooks. If you must use input, always set a timeout. Pipelines can hang due to infinite loops or network waits. Always set timeouts at the pipeline or stage level. Monitor agent disk space and memory, and clean up old artifacts in post always. Use Prometheus and Grafana to monitor agent resource usage and alert on anomalies. Avoid hard-coding environment-specific values like database URLs. Instead, use build parameters and environment variables. For sensitive values, use the credentials binding. This makes your pipelines portable across environments and reduces configuration errors. Shared library functions are groovy code that can have bugs. Write unit tests using Jenkins pipeline unit to test them in a JUnit environment without a running Jenkins. This catches errors early. We enforce that every shared library function must have at least one unit test. The article mentions integrating the linter into a pre-commit hook, but doesn't show the hook script. Here's a concrete example using a git pre-commit hook that runs pipeline linter via the Jenkins CLI, aborting the commit if validation fails. The @library annotation with a version tag, e.g., @library, mylib at v1, 0, requires Jenkins 2.7+ and the pipeline, shared groovy libraries plugin. In older versions, the annotation may be ignored, causing the pipeline to use the latest commit instead of the pinned version. Always test on your Jenkins version. The article mentions catch error, but doesn't show its usage. Here's a declarative example that marks a stage as unstable on failure while continuing the pipeline, useful for linting or code analysis steps. When using parallel with shared resources, e.g., a Docker daemon or deployment server, always wrap the critical section in a lock step to prevent race conditions. The article mentions this, but doesn't emphasize that missing locks can cause silent data corruption or deployment conflicts, especially in high concurrency environments. Blue Ocean provides a modern UI for Jenkins pipelines, showing stages, logs, and test results in a user-friendly way. It helps identify which stage failed and why. Use it for debugging failed pipelines, especially when console output is huge. Pipelines can fail silently. Set up monitoring to alert on failures, long build times, or resource issues. Use the email extension plugin, Slack plugin, or webhooks. Also monitor Jenkins health via Prometheus and alert on anomalies like high queue length. This is the same issue we highlighted at the start. Here's exactly why that happened. A developer committed a Jenkins file with an unclosed pipeline block. Jenkins tried to parse it but hit a syntax error, resulting in a cryptic no such method error. Because there was no pre-commit validation, the error made it to production, causing a 3-hour outage. A developer bypassed the credentials binding plugin by hardcoding the API key directly in the Jenkins file, exposing the secret in logs. The fix was twofold. First, we added a pre-commit hook that runs pipeline linter on every Jenkins file change. Second, we fixed the original Jenkins file by properly closing the pipeline block. Now, syntax errors are caught before they ever reach the repository, preventing similar outages. This missing closing brace caused the 3 a.m. outage. The pipeline block was never closed, leading to a groovy syntax error that manifested as a no such method error. Always use the pipeline linter to catch this before committing. Without a timeout, a pipeline can hang forever if a step gets stuck, consuming build executor slots and blocking other jobs. Always add a timeout directive at the pipeline or stage level to automatically abort hung runs. Hardcoding secrets like API keys directly in the Jenkins file exposes them in console logs and SCM history. Always use the with credentials step to inject secrets as environment variables, never as literal strings. To diagnose pipeline issues, start by validating your Jenkins file syntax with the pipeline linter. Check the console output for error messages and use Blue Ocean to get a visual overview of stages and logs. For resource issues, monitor agent metrics with Prometheus. Let's run through some common interview questions. Declarative versus scripted. Declarative is structured, scripted is flexible. Use declarative for most cases. How to manage credentials? Use with credentials step, never hardcode. How to use shared libraries? Store in separate repo, version with tags, load via library. And a few frequently asked questions. How to validate Jenkins file? Use pipeline linter via curl or CLI. How to handle secrets? Use with credentials step, never hardcode. How to prevent hanging pipelines? Set timeouts and monitor resources. To recap, always use declarative pipeline for readability, validate your Jenkins file with the pipeline linter before committing, store it in source control, and extract reusable logic into shared libraries. Implement proper error handling, never hardcode secrets, parallelize wisely, avoid input steps for approvals, and set timeouts with monitoring. These practices will save you from 3 a.m. callouts. Ready to go deeper? Up next, Jenkins security best practices, then Jenkins supply chain security, then Jenkins backup and restore. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.